Applied cognitive construction grammar is an approach to pedagogical grammar that stresses the role of a speaker meaning rather than the definition of an exhaustive inventory of constructions available to speakers in the linguistic system. As we may expect, ACCG explicitly pursues the development of pedagogy centered on ad hoc input. The type of input referred to in this paper is constructed upon corpus-identified constructions that may be relevant to specific L2 contexts, that are further organized in networks of motivated and semantically related constructions. The accurate identification of a construction is a requirement for their further introduction in the classroom. Unfortunately, such identification has been made thus far on the basis of classroom-based experiments with no real connection with classroom instruction. The theoretical turn suggested in this paper requires the construction of an interdisciplinary environment that integrates, for example, corpus linguistics theory, applied psycholinguistics, and SLA theory. As I have pointed out elsewhere, the combination of these rationales seeks to consolidate a distant usage-based framework that links construction grammar, linguistics, and psycholinguistics theory with SLA research. ACCG is clearly at the center of converging research traditions that study language as it mediates thinking, doing, and learning. This sets ACCG apart from both applied cognitive linguistics and applied construction grammar, the main difference being that while ACL and ACG seek to link directly psycholinguistic theory and research with L2 pedagogy, ACG advocates a middle way whereby an explicit pedagogical layer is introduced. In other words, the introduction of a cognitive linguistic type of pedagogical intervention depends on an unambiguous identification of the nature of the constructions to be taught, and not on making a class cognitive, especially when, in many occasions, the traditional instruction can do the trick. Once constructions have been identified and described from a sound theoretical and empirical perspective, this can be used to design ad hoc forms of input that maximize L2 reconstruction. To sum up, the present outlook draws on 4 tenets. Number 1, that language is learned through the conjunction of general cognitive mechanisms and the input in the context of usage. Number 2, the language is made up of form-function pairings. Number 3, the prototypical exemplars motivate metaphorical extensions within constructional inheritance network. And number 4, that syntactic constructions, argument structure constructions, exist independently from the verb semantics. The latter conceptualization has important bearings on the characterization of phrasal verbs. Thus, PVs are conceptualized at the level of an abstract, underspecified PV construction. PVs are constructions. PVs are motivated through metaphorical extensions. PVs are embodied, that is, they reflect specific body schemas entrenched linguistically in specific communities through usage. Embodied cognition presupposes that PV meanings overlap those of syntactic constructions by way of mapping of words to events or objects. Such mappings are possible because syntax is manifold, just as lexical items are. PVs are grouped into 4 main categories defined by phrasal verb ASC attachment patterns. 1. Verb locative. 2. Transitive. 3. Transfer caused motion. And 4. Detransitive. PVs are analyzed in the light of their attachment to the syntactic construction they occur in. Of necessity, this analytical shape requires a clear-cut description of the abstract syntactic constructions, argument structure constructions to which a specific PV is attached, which facilitates the transition from lexis to syntax for the comprehension of the various ways PVs reflect underlying semantic patterns. This is possible because speakers are prone to conceptualize the world through forms of embodied language determined by the architecture of their bodies, involving, for example, experiences with path, trajectory, and containment. These experiences are translated linguistically as metaphorical extensions serving as a reflection of the unique anatomical configuration of human beings. For example, human bipedal locomotion based on terrestrial locomotion experience constrains motion-related language to the extent that even metaphorical extensions echo more literal experiences. This is particularly obvious in languages which use particles to encode trajectory and direction, termed satellite-framed languages. As we can see in example 1AC, the language reflects embodied cognitive processes associated with metaphorical and transitive motion. The direction is encoded by the particle. Therefore, it is suggested that the indexical hypothesis provides anchor points for the integration of embodiment and argument structure constructions as a means to help learners to conceptualize PVs. The hypothesis entails 3 processes, namely indexing, whereby words and phrases refer to objects, affordance derivation, i.e., the definition of the properties of indexed objects, which are relevant for understanding in utterance. And finally, meshing, which consists in a combination of affordances into a coherent, i.e. envisionable and doable set of actions. Of central interest here is the fact that AACs are sensitive to indexation. Thus, the custom motion AAC profiles two arguments, specifies obligatory direct arguments, namely a transferred object, underscore, and a recipient, goal. As can be seen, examples 8ab associate animate causors and inanimate recipients with inanimate transferred objects. The combination of these affordances provides a coherent transfer clause in which the verb's meaning profiles specific participants. Interestingly, in example 8c, the combination of an inanimate causor, inanimate recipient, and an inanimate underscore is coherent thanks to the fictional character of the text in which these participants appear. By using specific templates, teachers can guide the learning of PVs in a cognitive way. Phrasal verb and lexical schemas are templates designed to unify language and action through an emphasis on embodied cognition in a fashion akin to utterance-based L1 acquisition. This includes a surface form, a cognitive scene, and an encoded manner. As shown in Figure 3, the PV reconstruction cycle introduces 4 types of motivated AAC PV attachment patterns on the basis of the 5 determinants of L2 reconstruction, namely frequency, function, recipient distribution, salience and perception, and type and token frequency. These are organized along a continuum moving from noticing and categorization back and forth on the basis of enriched forms of input in the form of both paper-based data-driven language learning and data-driven language learning texts. A good example of this is frequency-driven texts. These elaborate on corpus-identified ACCPV attachment patterns that can be used in the classroom as teachable prototypes. In particular, this type of texts draw on patterns of distribution of highly frequent PVS, also known as recipient distribution, whereby the highest frequency words account for the most linguistic tokens. In other words, the most frequent PVs in a corpus are the most prototypical and hence the easiest verbs to learn because learners are more frequently exposed to them in the input. One of the reasons for this is that prototypical PVs contain general-purpose verbs, e.g. go, make, take, put, come, usually associated with particles to express intransitive motion.